Welcome to the GOTO podcast. Each episode covers the brightest and boldest ideas from the world's leading experts in software development. Tune in for practical lessons, compelling theories, and plenty of inspiration. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
Hi, everyone. I'm Kurt Bittner, and I'm here today with my friend and colleague, Pierre Pureur, and we're going to talk about architecture, specifically continuous architecture, but we should lay some foundation first. And Pierre, people tend to throw around the word architecture rather loosely, and I'm curious about what the word architecture means to you.
And good morning, Kurt. Thank you for this conversation. This is going to be great. So for me, architecture is really, a classical definition, right? Defined as the fundamental concepts or properties of a system. And we think of it as elements, relationships, and design principles. So I think of architecture really at a conceptual level. And typically, the objective on architecture are to achieve some quality attribute requirements, to define some principles, standards, and blueprints. Of course, blueprints is what people think most about architecture. To build some usable, and if we are ambitious, even reusable services. And lastly, but definitely not last, to create a roadmap for some kind of IT future state. So those four things really define what architecture is to me.
So it's interesting, the quality attributes that you mentioned, and I know we're sort of jumping into something fairly directly here, but how do those quality attributes, what are they and how do they shape the architecture?
So quality attributes really, to us, I think of them as more important than functional requirements, because you can really design any kind of blob of software and that meets functional requirements. And yes, the good news, it will meet your functional requirements. The bad news, it will not really work very well. So quality attributes are really what define an architecture. And quality attributes tend to, there are a lot of them. They tend to change over time, the importance of them. So at this point, the ones in this age of cloud, agile, we think of quality attributes, the most important ones are really scalability. Because your system needs to be able to scale to a level to be able to handle your predicted volumes and number of users. Performance, because if the system doesn't perform well, basically nobody's going to use it, so you're dead on arrival. Security, because security is, as we all know, becoming more and more critical. And then resilience. Resilience is really making sure your system goes to production and stays in production, without having to really resort to extraordinary measures to keep it running. But those are the four quality attributes we are thinking of right now. They change over time, as I said.
Yeah, that resilience one is really interesting, because I think a lot of people think of architecture as being an upfront sort of thing. And in reality, at least in my experience, architecture has a lot more to do with the overall lifetime of an application or a system or a product, and so the resilience of it over time to changes in the environment, to changes in requirements, to changes in the people working on it, ends up being really interesting and drives a lot of interesting decisions.
Yes. Resilience, actually, you're absolutely right. Resilience has become very, very important lately. A long time ago, when we used to design, I don't even think we used to work architect at that time. We used to design and run system on mainframes. Resilience was really not a big concern. Mainframes were considered almost, they didn't break down. You could do anything you wanted and the thing would just run. Nowadays, it's not the case anymore. I mean, nowadays systems, you're going to have some hardware issues, some network issues, some software issues. So resilience has become very, very important. And it's really not a case of trying to prevent a failure. It is more a case of, well, what do you do if a failure occurs? Because a failure will occur. It's just a matter of when. And being able to gracefully recover from failure is becoming extremely important.
So you mentioned that these quality attributes tend to change over time. And so if you were to add a fifth one, is there a particular attribute that you think is sort of lurking out there on the sidelines that you might think of adding to this list of 4 that you mentioned?
Yes. So in retrospect, of course, we wrote a book about a year ago, so can look back and say, well, maybe I would do things a little bit different if I had the chance to do it again. We probably would have had, where I did the sustainability. Sustainability is a little bit, I mean, if I think of sustainability, the first thing that comes to mind is resilience, because to be sustainable, the system has to be able, of course, to stay in production. It's much more than that. Sustainability is really about, over time, to be able to, for your system, your software system, to really be resilient to changes. So to be, as things change, and things will always change, you need the system to adapt. And hopefully and that's an important consideration, at a manageable cost. Sustainability cannot be adaptation at any cost. It has to be basically adaptation at basically an affordable cost. So cost is actually also, the perspective of cost is kind of the invisible or the stealth quality attribute. Cost is always present, and you actually need to look at cost on anything you do on architecture. One thing about sustainability, I've read quite a few articles lately that really talk about sustainability in environment sustainability, really. Especially some cloud vendors are trying very hard to prove that their cloud is sustainable, doesn't really affect the environment too badly. And of course, with Bitcoin, that becomes even more important. I'm not actually thinking of sustainability in those terms, although environment sustainability is important. But I'm more thinking sustainability in terms of, over time, can your system react nicely to changes and at an affordable cost?
The principles are really interesting. What I would like to dive into next is basically, how do you get started with this? And for the listener who's not familiar, Pierre has written a book on continuous architecture along with 2 of his colleagues. And so this notion of what is continuous architecture and how do you get started with it? It's really interesting, because I think also my experience with architecture in the past is that people tend to think of it as being something that's upfront, and then you go develop it and you deploy the system and the architectural work is done. And so there's continuous from the standpoint of the development cycle, but also continuous from the standpoint of the actual lifetime of the system. And I think both of those attributes in a sense are interesting.
Yeah. So broadly speaking, at this point, there are 2 schools of thought about architecture. One is the one you described, Kurt, which is basically the upfront architecture, which is a traditional one. We try to do everything upfront, and we don't really write a line of code until all the architecture is nailed down. The problem with that approach is, of course, it's very hard to know everything at once. I think that, Kurt, you did mention that some people believe that something like 40% to 60% of requirements, and that includes quality attribute requirements, are really not true, not real. So designing an architecture when more than half your requirements are incorrect is definitely not to give you a good result. And also, it's really hard to predict how a system is going to evolve. So if you try to design everything up front, you're in, I think, for a bad surprise as time goes by. Plus, the reality is people are going to lose patience a little bit with the time it takes to get a design together. And people are really going to start kind of trying to get out of the starting gate and write some code. So for all these reasons, about more than 20 years ago, people moved to an agile view. And the idea of the agile view was the architecture was going to emerge. And you write code, and somehow the architecture, like a whale out of the water, kind of emerges. The problem with that is that if you do that, you're going to end up doing a lot of refactoring. You're going to do a lot of basically adjustment, because there is some planning you can do up front. Architecture is planning, and you should really attempt to do some planning. So when we started thinking about what continuous architecture could be, we started thinking about getting some principles. And none of the principles are terribly new or earth-shattering, but I think together they make a lot of sense. The principles, there are 6 of them. The first one was architect products rather than projects. And again, quite obvious, but people don't necessarily do that. Okay. The second one, focus on quality attributes. Don't worry too much about functional requirements. Yes, you need to have a system that meets these functional requirements. But again, if your quality attributes requirements are not met, then you're not going to have a very efficient system. The third one was really to attempt to delay decisions until you're absolutely sure that you have to make a decision. Don't make decisions too early. Try to make decisions based on facts. Fourth one, try to architect for change, because things will change. So try to think small. That doesn't mean necessarily use microservices, but think small design if you can. Fifth one, don't forget, build is fine, because most people architect to build a system. Don't forget you're going to have to test, to deploy and operate the system. And that's almost more important than building a system. And the last one is really the well-known principle of model the organization of your teams after design of the system you're working on. Basically, if you try to organize your development group in layers, front, middle, back, that's not going to work very well. The idea is try to more cut across layers and have one kind of nice, homogeneous team that really deals with all aspects of the system. So those were the 6 principles.
And those reflect a lot of the similar experiences that I've had too. That having an empowered, self-managing, cross-functional team that's focused on delivering value is one of the really sort of foundational aspects of agile approaches, and a lot of people lose sight of that. One of the things that was really interesting in that is that notion of delaying decisions until absolutely necessary. And so one of the questions I think teams would ask themselves is, how do we know when a decision is absolutely necessary? What kind of questions should we be asking ourselves about decisions to say, to answer the question, or to say, we don't really need to make that decision right now. We could delay it until later. Or the converse of that is to say, we really need to make this decision right now, because this is going to fundamentally affect a lot of work going forward. And maybe, I'm sure you have some thoughts about that. We've had some conversations, I know, about those things.
Yes, I mean, I think one of the key attributes of an architect is to be patient. Okay, don't rush into making decisions too early. In my experience, I've seen teams that really start with the end in mind, and they know they want to bring some technology, and the reason could be because someone told them, well, we know we need to basically be on the Amazon cloud. So just, the answer is going to be Amazon cloud. And you don't even think of the question. Well, if you do that, the problem is you're going to miss a lot of things. And so the idea is to be patient and really make your decisions when you have all the facts. And that's important. Don't try not to make decisions based on guesses, because at least half the time your guess is going to be wrong. If your guesses are wrong, your decisions are going to be wrong. Okay? Try to make decisions when there is no other choice, when you really have to. Okay? Don't wait too long, but don't rush into making decisions. One thing I will offer as a piece of advice is beware of bringing in products, especially rules engines, that may hijack the architecture. Okay, make sure the technology doesn't really take over the architecture, because that's really a problem. Okay, and then we get into cost. Back to cost, right? Okay, some decisions are going to be not accurate. Some decisions are going to have to be reversed. So for each decision, there is a cost of reversing the decision. So I think by looking at basically the cost of that decision, or reversing the decision when you make that decision, you can actually get to a point where you can actually ask yourself, do I really need, am I absolutely sure that I have to make the decision right now, or can I wait a little bit longer?
Yeah, that's when we were talking about this last week. It occurred to me that if I put this into Scrum terms, then I might say something like, during sprint planning, the team should ask itself, is anything that we're planning to do during this sprint going to have an unacceptable cost if we have to redo the work at some point in the future? So inevitably, as you said, our architecture work involves rework. You want to minimize that, and yet you don't want to lock yourself into particular technologies or decisions if you find facts in the future that tell you that you need to do something different. So I think that notion of unacceptable cost is an interesting question for people to keep in the back of their mind anytime they're planning work, and say, if we have to redo this in the future, does it have unacceptable cost? In that case, then you need to make a decision now, and you need to understand the consequences of that decision. Would you agree with that?
Yes, so absolutely. And more and more, I think of architecture as a continuous flow of decisions, because that's really, people think of architecture as blueprints, nice diagrams, and so on and so forth. Yes, you have to have those things. You have to communicate as part of the architecture, but most importantly, within the basic unit of work of the architect, an architect really produces decisions. Doesn't necessarily make decisions, but facilitates decisions. And as you make decisions continuously, you're going to learn. You're going to have this continuous loop of learning. And you're going to learn from your mistakes, because you're going to make mistakes. Everyone does. And as you learn, you're going to go back and revisit your decisions continuously. So you're going to kind of have this kind of full feedback loop and circle where you gain knowledge, you make a decision, you gain knowledge, and you revisit the decision constantly.
Yeah, that's really interesting. One of the things that I've always tried to practice, and if I were to add a principle to your principles, I might say, make everything replaceable, or make everything replaceable at relatively low cost. And so that argues for very modular code and very isolated services with loose connections between them, and lots of things that are sort of becoming either widely adopted now or more prevalent. So one of the things that sort of relates to that and relates to this question of how to get started is something that I know you and I have talked about, this concept of a minimum viable architecture. In a sense, what does the first iteration of that architecture look like, at least at a conceptual level? And then from there, you can start iterating and improving and learning and replacing. But how much architecture do you need to get started?
Yes. So the concept of minimum viable architecture came out of the minimum viable product concept. And that kind of follows principle number one, which is basically think products, don't think projects. So most often than not, your first step in a minimum viable architecture is going to be to support the implementation of a minimum viable product. Something which is small, but good enough to be put in production. And that's a key word. I mean, you need basically your first iteration has to be something you can actually put in production, because the whole point of the minimum viable product is really to get feedback from customers. Well, you can't get feedback from customers if you don't really have something in production. So the first iteration, and what I'm thinking of the first iteration of MVA is really to have something that supports a minimum viable product functionally. So your MVA is it's going to be good enough to basically to be put in production. However, okay, you're not going to design an MVA based on guesses. We go back to facts versus guesses. So you're going to basically design your MVA based on what you know. And if I'm thinking about performance or scalability, you're not going to worry too much about scalability because the MVP is probably not going to be released to a lot of customers. So you're going to have a small customer base. Performance is going to be good because typically, if you don't have a lot of users, performance traditionally is good, okay? And resilience is also going to be acceptable. Security, however, is still important because you don't want to put something out that is not secure. And then I happen to believe that if there's one thing you should do initially is to put some kind of instrumentation framework so that you can monitor the performance and scalability of your system. So as your system and your MVP becomes popular and successful and expands, and we hope it does, at that point, you're not kind of caught flat-footed and you're not basically facing a big problem. So you know your implementation framework is going to tell you basically, oops, be careful because it may be time, and this is all part of the feedback loop, it may be time to actually start considering performance scalability because your system is being used by a lot of people, so more than you expected. So time for a second iteration.
Yeah, it's a really interesting concept because I think a lot of people in that minimum viable product, they tend to focus on functional requirements, and so they'll have a nice sort of, in the old days we would call it a demo. They'd have a nice set of visual capabilities that would be very exciting and get everybody really interested. But your discussion reminds me of something that I did with a team years ago, and that we had an online transaction processing system, and we had certain in a sense, service level agreement kind of things about how scalable the distributed system had to be. And so there were certain requirements around latency and certain requirements around response time and certain requirements around number of concurrent users. And so our first iteration on this particular application had virtually no functional requirements, but what it did is it simulated the workload that would be happening in that system. We knew approximately what kinds of things would be exchanged back and forth, and so we wrote our first sort of minimum viable architecture in your terms to basically start up that many concurrent users, start up that many concurrent processes, simulate the distribution and the lag time and latency in the system, and prove that some of our most basic choices could actually be satisfied. Because if we couldn't do that, then we just really needed to cancel the whole initiative or significantly rethink it. So that gave us a lot of confidence. And then from then on, we could start replacing the fake transactions with real transactions and gradually building the system out. And it very much worked in the way that you described with, making these decisions over time. We weren't concerned about the functional requirements initially. It was more the scalability, security, reliability, and latency kinds of requirements. Very, very interesting.
And there's actually one more point on MVA and MVP. Traditionally, an MVP system, minimum viable product, is a throwaway system. That's how people think of it. And that's what I definitely differ from that school of thought, because I really believe that the idea of an MVA is building something going to be able to grow and build upon. And I think that's a key thing. Yes, you roll out a minimum viable product, but you're going to build that product and you're going to build the architecture in tandem. So, if you're lucky, you're going to end up with successful full-fledged system. If you're unlucky, the system will not go anywhere, but you will have learned a lot, which is really important.
Right. Now the question, I think, in a lot of people's minds, certainly in mine, is that architecture work is really, it's not easy, but it's less challenging on a new product. But if you have existing products, or you have a new product that relies upon existing products for some transactions or services that it provides. And that existing architecture is just often a mess. It's just a tangled web of dependencies and other things. And somebody I talked to one time said, if you use the building analogy, it resembles a ruin rather than a functioning building, a ruin that people are squatting in and living in. So if how can an organization basically apply continuous architecture concepts to a bunch of existing systems that they already have that they need to extend or that they need to build on top of? And maybe let's start with that question, and then we can move on to a related one.
Yes. So it's actually interesting, Kurt. On Friday, I was talking to a common friend of ours who happens to be in London right now. And we're talking about exactly that topic. And Murat, of course, I'm talking about Murat. And Murat right now works for a large international bank. And when I was talking to him because they are going exactly through that, they're going through basically a re-engineering of systems. And when I asked him about, how those decisions made, decision to start over versus to try to keep on updating and enhancing, his answer was very, very direct. He said those decisions have often to do more than politics than technology. Basically, what happens is you get someone at a very high level that says, well, I had it with systems working on mainframe and so on and so forth. Time to move to a modern cloud. Time to basically move to Amazon, Google, or pick one, right? Nothing really to do with technology. So kind of leaving that aside, okay, I think that the main issue with systems that have been around for a long time is that technical debt builds over time. Technical debt is like entropy, okay? It's very hard to avoid technical debt. Every decision we make and kind of involves some technical debt. If you're lucky, when you make the decision, you get no technical debt, but that's luck, okay? Most of the time, you end up with being saddled with more and more technical debt. So what happens over 10 years, 20 years, 30 years? Basically, at some point, your technical debt becomes impossible to repay. And you need to do something. You get to an inflection point where you say, well, do I really want to keep on kind of modifying the system, enhancing the system, and really spending a lot of money on trying to really make the system a bit better, or just keeping afloat above water? Or do I just want to give up and start again? Another factor in this, in addition to cost, is some systems become impossible to use to really support the business strategy. It's becoming impossible to actually roll out new products. Okay, if you reach a point where the system stands in a way of a business strategy, then you really have no choice but to really scrap and start over. Okay, if you haven't reached that point yet, okay, and if you think that the system, and this is really almost an ROI, return on investment discussion, because at some point, okay, the cost of basically maintaining the system is going to be really too high, and you don't really get enough return on investment. So there's a way to actually start replacing your system kind of piece by piece, service by service. And that's basically an example of that is the so-called strangler pattern, where you strangle a service in your system and you replace the service with a new system. And that can work to a point, except that some older systems are really far too really compact and monolithic to really be able to be kind of modernized service by service. If that's the case, you have no choice but really go back to square one and start again.
One thing that I find really sort of exacerbates the dependencies between systems, which is often what, you mentioned monolithic. It's because there are too many dependencies between things. But one of the things that I've noticed is that it helps to start abstracting the data and not be tied to specific database schemas and not interact. Basically, use services between different parts of the application rather than common data. And that's a problem in a lot of older systems, is that they synchronize basically by using common data and common databases, and then that tends to ripple. Switching gears a little bit, I'm sure a lot of the people listening to this are interested perhaps in how do I become an architect? How do I approach this from a career standpoint? So, one of the questions that we've talked about before is the question of, is architecture a role or is it a skill set? And then if it's a skill set, what are the skills of the architect?
So I'm absolutely in a camp of saying architecture is becoming a skill set, not a role. Okay. I predicted a few years back that architect as a job description will disappear. At the time, I was chief architect in a large insurance company, so they didn't make me exactly popular, but that's unfortunately for long lifetime architects. I think that's happening now. So in terms of skills, okay, you need, you're not born an architect. I don't think that people are basically, so some people are born with specific skill sets, the ability to conceptualize, which definitely helps. But I don't think there's anything magic about being an architect. In order to be an architect, you have to, first of all, you have to be able to design. Okay? I mean, architecture is a design-oriented activity. So if you can't design, okay, you're not going to be a very successful architect. So designing is important. Leadership. Okay? Architects are technical leaders. Another friend of mine used to say that 50% of architecture is communication. So you have to be able to lead and communicate clearly. Communication skills are critical. Okay? Stakeholder focus. Architecture is about really serving your stakeholders. It's serving a business. If you're only focused on technology, you're not going to be a very successful architect. Okay, so it's all about really focusing on number one, knowing who your stakeholders are, and number two, focusing on those stakeholders. This goes back to products versus projects. Okay, conceptualization. Architecture is all about concepts, right? You need to be able to conceptualize and address system-wide concerns. Okay, architects are not just concerned about one little module. Okay. They are concerned about the whole thing. They have to be able to look at one module, but they have also to be able to look at the whole story. Okay? And they have to be able to focus on systematic qualities than detailed functions. That's very important. Back to quality attributes. Life cycle. Remember principle number 5, right? You have to be able to basically architect for build, test, okay, deploy and operate. You have to really to be involved in the whole life cycle. You can't just think that you're going to build something and throw it over the wall to some other people. No, it doesn't work that way. And then the last one is the ability to balance concerns and compromise. Architecture is about compromising as well, making decisions and compromising. Most often, you're going to have a lot of, at least 2 of your quality attribute requirements that are going to conflict. Okay, performance may conflict with usability. Okay, security may conflict with a lot of quality attributes. So you have to find a good enough solution. You have to be able to really compromise. That's really harder to do than it's said. So that would be kind of my quick list of skills.
Mm-hmm. Building on that a little bit too, I think about experiences that I've had and that people I know who I really respect as architects seem to have had. And this is more just adding a little bit of detail to some of the things you mentioned, but having to support an application in production, understanding what happens with load, understanding what happens with security, understanding how to instrument the application to anticipate failures, knowing what kind of things you have to do, the kinds of things you have to do quickly when you need to patch something and get it running again, I think helps you really understand what happens and how to make that application more supportable. I think, my own, introduction or the start of my education around things like architecture, I was both building and supporting building the application, supporting in production. So that I learned a lot from that. The other thing that I think helped me early on was a stint that I did in a job where I was focused a lot on performance and scalability. And it gave me some insights that I would not have had if I was just building and deploying applications. So I was actually doing a lot of performance tuning. And then I found I learned a lot as a developer from having to maintain and modernize somebody else's code. So, you start going into someone else's code and you look at it and you realize this is just a mess. And you start seeing mistakes that you make that other people are making. You start recognizing, oh, wait, I make that same error, whether it's from, having various kind of services that don't have weird side effects or other things, isolating different parts of the code. So, I find those things, if I was recommending to someone, who's maybe just a developer starting out, I would say, try to get those kind of experiences, because you'll learn a lot from having to maintain someone else's code. You'll learn a lot from supporting an application. You'll learn a lot from maybe even doing some work in operations. And I know a lot of developers don't like the idea of having to do that. That's maybe not the fun part, but it's something that pays a huge dividend over a long period of time to really understand what happens to things in production. And so that's some advice I would add to what you said.
Yeah, absolutely. I mean, I think, Kurt, when we started with these careers, basically people didn't worry too much about, when you were in development, you didn't worry too much about how the application was going to do in production. You certainly didn't worry about scalability, because mainframes, right? It was great. Mainframe was there to scale. And if you didn't scale, just bought a new mainframe. One hopefully will scale better. Security was definitely the domain, and until fairly recently, the security was the domain of some people in a room, usually well locked. You couldn't get into the security, the location where your security engineers are sitting. And all you knew is from time to time they would get out of a cave and run some kind of mysterious code against your code that will basically flag all your security problems, and then they will disappear again. These have changed a lot. Nowadays, security is everybody's problem, and especially it's architect's problem. So if you want to be an architect, you have to get involved into performance, scalability, resilience, security. That's absolutely critical.
Yeah, security is an interesting thing. In the old days, everything was physically secured. So, you had to have a badge to get into the room with the computer. Once you open everything up to the internet, then it's a whole different set of problems. So one of the interesting things about, when I think about continuous architecture, I also think about continuous delivery. And one of the keys to making continuous delivery really work is having a very high level of automated testing coverage. And so I'm wondering if there are some examples and some other things you can bring to, how do you start testing those quality attributes early and build that into your automated delivery pipeline so that you can really have automation support and more than just, sort of thinking. So continuous architecture isn't just the way you think about the problem. It's actually the way that you start instrumenting your delivery pipeline. Are there any things that you can suggest there?
Yes. When people talk about automated testing and other shift left movement, you try to test as early as you can, they usually talk about functional testing. And that's great. But, we are back to the blob, right? You can functionally test the blob of software. And yes, it's going to meet your functional requirements, but it won't perform at all in production. So the idea is really try to test your quality attributes as early as possible in the process. We're kind of shifting left in automatic testing of quality attributes. The one that comes to mind is performance. Okay. I think that performance testing should be part of every automated functional test. You should really build a test harness and a series of tests that test performance basically as you integrate your piece of code to the system. Okay. But scalability, you probably are not going to test scalability every time you run a functional test, but you probably want to test scalability quite often. And again, automate your scalability testing. And there are a lot of possible scalability tests, but the idea is you need to be able to do some of those tests, okay, which really gets us into resilience. Okay, at some point, you're going to stress test your system, which really see, okay, so how, and you're going to do that automatically, and you need to do that often. I still remember times when performance testing was something you did at the end of a life cycle. Okay, so typically 2 or 3 days before going to production, you performance test your system. What's wrong with that? Well, what's wrong is obvious, right? The problem is you're going to find out, usually, when everybody expects a system to be in production on Monday, you're going to performance test your system on Friday. And more often than not, you're going to find out your system is not performing. And what do you do next now? You call off the implementation? You're not going to have a lot of friends doing that. You go in with a system which doesn't perform. That's not going to work very well. Scalability is the same. So in order to avoid this Friday kind of crisis, you really have to test continuously your performance scalability as well as your resilience. Google, I believe, came up with the concept of simulation army, okay, which was the whole idea was you start disrupting your system. You don't do it, of course, every day, but you start disrupting your system because it's much better to actually start disrupting your system in test than it is to be at the receiving end of a disruption in production, okay? And then, of course, security. That's probably the one that people are most familiar with. But again, the whole concept is really don't really run a security inspection code. A code inspection for security at the end of the process. Do it at least, once a week or from time to time to make sure that you don't have to have problems in your system, in your code base that cannot be resolved quickly.
Yeah, those are, you mentioned the Google concept of the Simian army. And I also remember there was a similar kind of thing at, I believe it was Netflix, and they have this chaos monkey idea where literally they inject random failures into the system and then force people to deal with that, the developers to deal with that. And in the security area, that something comes to mind is the idea of ethical hacking, literally having people trying to hack into your system to expose security flaws. But of course, people that in a sense work for you, or at least are working against you, but ultimately in your long-term interest, I think is an interesting technique to throw in, because the problem with many of these things is you don't know what you don't know. And so having someone else coming in, injecting, real world kind of errors or real world kind of hacking or security breaches into your system is ultimately a good thing, because developers can very often have kind of a tunnel vision where they can only see the kinds of problems that they have encountered before. They're not familiar with perhaps new kinds of ways to get into the system. So I think that those are really interesting ways to make sure that the architecture is evolving as you're developing it, as you're developing the rest of the application.
I was going to say the message here is don't wait for the Friday before you roll things into production. Basically, make sure that your test, performance, scalability, security, resilience are run often so that you can learn from that and hopefully adjust your decisions.
One of the things that architects have been accused of doing in the past is basically, in a sense, continuing to polish something, and perfect it well beyond, in a sense, to overinvest in perfection. And so I think an interesting question is, how does an architect decide what is good enough? Because, it's never going to be perfect. And, you can waste a lot of time and effort, in a sense, developing a solution to a problem that doesn't exist. So how does I can see how continuous architecture might work that way, but I think, could you say a little bit more about that?
Yes. So remember principle number one, right? You're trying to develop a product. not a project. So the difference is really a product has a long-term view, but also you want that product to be in the hands of your customers early, minimum viable product, so that you can get feedback. The whole point is to get feedback on what you have done. So basically, I think that, waiting for a system to be perfect is pointless. What you do is you really build a system which is good enough, meets your quality attribute requirements as you know them, not the ones that may happen a year from now, but the quality attribute requirements that you know them now, okay? And you move the thing in production. And most important, you instrument, so you can collect feedback, both on a functional basis. Do people like it? Do your customers like it or not? Do they use it? And on a non-functional basis, which is, does the system really perform to expectations? Does it scale? And so on and so forth. Based on that feedback, you adjust your decisions and you keep on going and going and going. So the number of cycles is infinite. I mean, you're going to be cycling forever. But the thing is, you build a system which is very, very resilient to change. And at the end of the day, it is sustainable, which is really the goal.
Are there potential traps that people can run into that they go too far down a particular path? And how could you recognize that you've, in a sense, you're going too far down the path? And what I see in what you just said is that there's this balance between meeting the needs that you have today and anticipating the potential growth tomorrow. So I don't know if this happened to anybody. Yesterday was the Super Bowl, and there were ads run on the Super Bowl, and I remember having a conversation with someone one time, and they used this phrase that I really love called catastrophic success. And what that was is that you're a little startup, you run it, your company buys time, runs an ad, gets a lot of interest, and all of a sudden you have orders of magnitude more interest in your product or your website or your service than you've ever had before. So, I see that, there's a certain amount of meeting the needs today, but anticipating the possible sort of growth of that product over time, so that you're not caught up in a sort of a catastrophic success kind of thing. And all of a sudden your product takes off and you have a lot more things. So maybe that would be one thing that we could talk about, and then I want to get to one other last question. Yeah.
So very quickly, because I think we are running a bit out of time. I think one of the best examples of what you described, Kurt, was what happened in 2020 with the COVID situation, where a lot of people basically work from home, and they got into retail trading of securities. And a lot of companies got very badly surprised with the volume. I mean, I'm not just talking small companies, not just the Robinhood of this world, but also large brokers and large investment companies. And they started really having some outages. And the outages will happen at the worst possible time, typically when the market was gyrating crazily. And when people wanted to trade, they could not trade anymore. So how do you prevent that? There is no perfect recipe, but at least as part of your resilience strategy, you can build enough guardrails so that, number one, you know what's going on. This is why instrumentation becomes so important. You know exactly what's going on. And number two, you recover from failures. And, there are strategies on that. There are tactics on that. We actually, in a book, we talk about quite a few of them. Bulk words, circuit breakers, and so on and so forth. The idea is really to try to plan for failure. So to try to kind of realize that failure will happen. Okay, your ad will be catastrophically successful, to use your term. And basically, what's going to happen is you're going to have a volume which you don't expect. What do you do at this point? Well, some people believe when you run on a cloud, some people believe scalability is a problem with cloud provider. It's not. Okay. It doesn't matter how much horsepower you have on your infrastructure. At some point, you're going to run out of something and your system is going to collapse. So the whole point is to anticipate that potential collapse and to try to put measures in place that will avoid a catastrophic thing happening.
Great. Well, I think just to wrap up, this has been a great discussion, and I always learn a lot from talking with you. I think to leave the listener with, could we leave the listener with a couple of ideas they could maybe just get started with tomorrow, just regardless what their role is, whether they're an architect or developer or perhaps a manager who's got some oversight over teams that are dealing with architectural issues. What are some things that people could take away to get started, other than reading your book, of course?
Yeah, of course. So the two things I would definitely advise to our listeners to look at to get started. Number one, look at the principles, the 6 principles. I mean, they are very, very useful. Again, they are not revolutionary, but they really kind of, they define how we think about architecture. But the second thing are really the 4 quality attributes. The 4 essential activities. Okay. And basically focus on the quality attributes is the first one. Okay. That's very important. Drive and revisit your architecture decisions. Okay. It's all about decisions again. Decisions important. Okay. Know your technical debt. Okay. Anything you do is going to basically affect your technical debt and probably, okay, have an impact on cost. And the last one is implement your feedback loops. Feedback loops are so important. It's important to know what happens to your system. Again, nobody is 100% right. You're going to be statistically going to be 50% of the time you're going to be wrong. And it's important to learn from your mistakes and get better decisions next time around.
That's really great advice. And for those of you who want to learn more about this, I read the books, both the original Continuous Architecture book and the applied book, and I'd recommend reading both to learn more. So anyway, thank you, Pierre. Thank you for a great conversation.
Thank you. That was great. Have a great day. Thank you.
Thanks for listening to this episode of the GOTO podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.